Welcome to the Dapr community call. It's September 21st. Thank you for joining us. We have a pretty packed agenda, so I'm just gonna kind of jump in. We're gonna be discussing the version 1.31 hotfix. We've recently released 1.4, and we're gonna show a couple of the new features there, which include HTTP proxying that Jeroen's gonna show, pub sub routing, that Phil's going to show, and then have a discussion about Dapr logging capabilities that Sander and Edwin are going to lead. And then a note on the new JavaScript SDK that Xavier has worked on and is the maintainer of. But I want to first kind of say that if you don't know, we did release Dapr version 1.4, which is pretty exciting. So if you haven't seen, we have a blog post about it, and these are the release notes. Part of what we discovered working towards this release is that there was actually an issue, and Hal's going to go into that in depth. So if you're not aware, there's actually a version 1.31 patch hotfix that was put in place to allow you to have a zero downtime upgrade if you're running in production, and require that to smoothly upgrade from version 1.3 or any earlier Dapr version into version 1.4. So this is a little bit of the context of how version 1.31 came about. It actually came about really close to version 1.4 for that reason. So I just wanted to make people aware of that. But the latest version that we have right now is the version 1.4. If you're just starting out clean, if you're just installing Dapr, this is the latest one that you're gonna get. You see it's the latest released up here. But to discuss a little bit more on that version 1.31, I'm going to turn it over to Hal to kind of give us a rundown of what the bug was and how upgrading looks like. Go ahead, Hal.
All right, thanks, Ori. Let me share my screen. There we go. All right. Essentially what happens, or what I'm going to go over here, is how we can safely upgrade from 1.3 to 1.4. And in a scenario where you're in production and you really can't handle any downtime. So what happened with this release is actually in 1.3, there was a change introduced that essentially made the Dapr sidecar crash or fail if it could no longer connect to the operator. So essentially what that means is, when you can't connect to the operator, it's because, when the operator restarts, you're going to lose connection. When you do an upgrade such as this, the operator restarts, and basically you will be guaranteeing yourself some Dapr sidecar restarts, which isn't the ideal scenario for your upgrade. So that's how we made or came across 1.3.1. As it turns out, the fix that we needed was actually already in 1.4, but again, you can't upgrade to it without it. So we had to do some little extra steps to kind of get us there. In this case, it's specifically using Helm to upgrade your Dapr sidecar injector to 1.3.1 by itself, and then doing a rollout restart before moving on to 1.4 as usual. So just to demonstrate that, I'm going to go through, what we have here, and show kind of what happens when you don't do this, and then also what happens when you do, and kind of see it working in action. So the first thing I'm going to do is this is actually just the I'm using the long haul test that we actually run constantly to verify our Dapr workflows in the background. I'm going to run one of the applications from that, specifically this little pub sub workflow here. So I'm resizing my window by accident. This pub sub window right here, or workflow right here, simply because all this does is publish and subscribe to its own topic. And then also this application happened to have a very poor time handling the restart. So it gives me a little bit more time to show you what's happening and how that and kind of why it's important to do the 1.3.1 upgrade before you do this. So you can see I have a running app. We got 2 out of 2, which means that both the app and Dapr are up. So now we can kick off a runtime update. And once this finishes, doesn't take super long. we'll be able to see kind of the bad case that's happening. So now we wait for just a little bit.
So meanwhile, while we're waiting, I see that there's a question about upgrades that are zero downtime.
Yep.
And I think our goal was to have, I think Yaron just answered that actually, having all upgrades be zero downtime.
Yes.
This just broke this in version 1.3, and this is the way to mitigate that.
Yep. And you can see here that going from 1.3.0 to 1.4.0 directly, I have my app here. It's erroring out. The reason it's erroring out is because this app is also specifically not resilient to this like extra. So you can see, that's why I chose it. So you can see the fact that it is erroring out. But now I can show you how to do it correctly, which is going to involve a little more running backwards and forwards. But in the meantime, I also talk about this a little bit here. With 1.4, we introduced the pub sub routing feature. It's currently in preview, but it does involve an upgraded CRD. So it has an upgraded CRD, and with Kubernetes, when you have an upgraded CRD or a new version of our CRD, you're actually not allowed to go backwards because it's removing some of the functionality, and anything you deployed under the V2 of that CRD will be deleted. So this is also a change with 1.4 is now the CLI can detect when you're going backwards, and if you are, it will no longer try and put in the old CRDs. And that's fine because CRDs are strictly additive. So it won't change anything else in your system. It just allows anything that was there under 1.4 to continue. And to answer Federico's question, self-hosted modes doesn't have an upgrade path like this. You can notice that I have the -K here. Because when you're upgrading on self-hosted, you just do a new Dapr run, and that is the new version. All right, so now we get into the fun stuff. We can actually check to see if my guy came back. Okay, so yeah, so you can see my application came back. And now what we can do is we can do this, and we can do our Helm upgrade. So essentially all this is doing is that it's setting what string or what version for the sidecar to pull. And now we can do a restart of my application. The reason you do this is because it takes this makes the application take the new runtime version. And this is different than taking downtime because yes, we are restarting the application, but you can see when you do the rollout restart, we actually have two applications come up, and you won't see the other one, well, for some reason had an error, which is, there it goes. I'm not sure exactly why I had an error during this exact instance of me trying to roll out and restart it, but the point of the rollout restart is that we have one application that is running the whole time. So you still have something that's taking traffic, and that's kind of the benefit of the environment like Kubernetes. And there we go. Now you can see I have my new one that started, the old one's gone now. So now what we can do is we can go back to our upgrade to 1.4. And we'll have to remember that this one did restart for whatever reason when it first started. But this number should go from, or shouldn't change, should be 1 to 1, now going from 1.3 to 1.4. So now you wait again. Go. And you can see that my application is still running, and we have not had any additional restarts. So there you go. So that's the path of how to upgrade from 1.3 to 1.4 with our intermediary step of 1.3.1, and that's how you keep your zero downtime upgrades going.
Great, thank you, Hal. And I pasted in the chat a link to the docs where we have a table of the upgrade paths for any release to any of the latest releases. Let me share my screen real quick. So you can see in the docs under operations, supported releases, we obviously have all the supported releases that we have. And as you recall, or I hope you know, and if you don't, then it's good to know that we support one release back. So you can see, for example, once we release 1.4, 1.2, and all the hotfix fixes after that are unsupported. And to upgrade, you got upgrade paths here, how to do that safely. And you can see to upgrade to version 1.4 from any of these, you got to go through version 1.3.1. And that's basically the essence of this hotfix. So with that, we can go to the next topic, which is HTTP proxying your own. Feel free to start sharing.
Thanks, Ori. Let me share my screen. All right, can you see this?
Yeah, we see your screen.
All right, awesome. So in 1.4, we introduced more ways to call Dapr for service invocation. And if you've been using service invocation so far, you know that this is what the API looks like. You're basically calling to your local Dapr sidecar, localhost, port 3500. You specify the API version. You tell Dapr, hey, there's a /invoke here. You give it the app name that you want to invoke, and then there's a method fragment, and then you basically input the method. Now, this might be a full URL route of some API like /product/v2/add/whatever. And a change that was done in this release by Ian Luo from Alibaba. Thanks, Ian. You're not in this call. But if you're watching this, thanks for doing this, is to basically allow for an easier lift and shift scenarios to come into place. So if you have an existing application, we basically introduced an easier way to call into Dapr. And before we take a look at what this looks like in docs, let's actually see the code. So I have here a Python app that's calling an OGS app. This is taken from the Dapr Hello World Quick Starts. This is just a very simple Node.js app. There's nothing important for us here. We just need to note that the Python app will be calling this method. That's it for new order. Nothing else to see here. We're moving along to the Python app. And this simple Python app has a loop where, and I just zoomed in a little, where it's calling into Dapr and it's saying, hey, Dapr, on localhost with the Dapr port, invoke node app, and the method I want you to invoke is new order, which is the method we've just seen. And then there's a loop that's going on, and we're basically incrementing the value here and just sending it and printing a response if it failed. So let's see how that looks like if we're not changing anything. So I'm just going to do Dapr run here, and I'm using the Dapr CLI to run the Dapr sidecar and the Node.js app. That's listening, and now I'm going to use Dapr run to run the Python code. So we have an error here for Redis. Yeah, that's an error that I sometimes get with Redis, where I actually need to restart it. So let me restart Redis right here, and we'll make sure that it's working. This started happening with the latest Redis update that I took. Sorry, with the latest Docker update that I pulled from about a week ago. So we can see the Docker engine starting. It will take a while, just like 20 seconds. So we're in the Hello World terminal here. Let's go back here. And wait until Docker comes up so we can continue the demo. All right. Looks like it is running. Yeah, up to 13 seconds. All right. Let's go back to the terminal. We'll do Dapr run, and we will be running the Node application. So that's running. Now we'll run the Python app again. And we can see that it's running. So we'll go back to Node, and we get the orders, and we're successfully persisting them. All right, so everything's working nicely. So I'm just gonna stop these two here. And you know, if you've had an application that used some hard-coded DNS name before Dapr, your app would probably look something like this, right? You would have something like some DNS dot some address with new order. And if you're coming into Dapr, you'd basically need to take the Dapr URL and change a lot of things in how you format your URL. So what we did here is allow you to basically just say, hey, localhost, just target the Dapr port, right? Same thing as before. And you don't need that whole invoke with the special fragments that we had before. So you can just keep your URL as is and just change your hard-coded DNS to Dapr, because Dapr does the service discovery for you. The only thing that we need to add is, of course, the target app ID. So this method really has the URL decoupled from the mechanism to discover the app. So this URL basically stays the same, and the only thing we need to do here is just add a header with Dapr app ID, and the app ID that we're trying to discover is, of course, NodeApp. All right, so that should be all. Let's go back here and run our NodeApp, and it's running. And if we did everything right and I didn't set finger anything, then that should work. All right, let's go back to NodeApp, and we can see that this URL now is working too. So this just makes it a little bit easier to integrate Dapr into existing apps, where you don't actually need to change your whole URL. You basically just change the basic HTTP scheme of your URL, and then you tell Dapr on a per call basis what's the app ID that you want to actually invoke and discover using headers. So this is very much in line with the changes we did for gRPC proxying in 1.3, where now you can use your own protos, and the only thing you really need to do is change your gRPC client to localhost instead of the hard-coded address of the service that you were calling to prior using Dapr. Now, there is one more URL that we're allowing, URL format, which is this. So it's HTTP, and then you can put the Dapr app ID and the app name here in the schema at the Dapr address and its port. Personally, I don't like this as much as I like this one. I would advise, if you're doing HTTP service invocation, I would advise using this. It's just a lot cleaner, and it just much better with, HTTP, with the way HTTP does things. I think it's a lot better than, this method or this method, but, you have the option, and you have the power to choose which one you would like to use. All right, so that's it. Stopping the screen share.
Great, thank you. And I saw a question in there, but I think Paul answered it about the app ID being required. Just from the lack of time, I'm just going to move ahead, and we can maybe go back and answer more questions in the open discussion. So from this new feature to version 1.4, Phil, take it away with pub sub routing, which is also new to version 1.4.
Yes, hopefully another feature that we've added that helps your life. So I've posted links to everything I'm going to talk about in the window there, so you can grab them while we have this meeting open. But the first thing I'm going to show, I'm going to share my screen, is the docs page that we've created for this new feature we've called pub sub routing, right? Which is, the how-to is how to route messages to different event handlers. And if you expand upon that, the real functionality is to inspect cloud events. So Dapr, as many know, Dapr adopted the cloud event spec. So it's a standard structure for articulating events that are coming from PubSub. And there's a lot of advantages to that. It's a standard in which you can get message IDs from a different type. You can add things like tracing, so that actually makes it so Dapr can trace the message all the way through the flow of where that message is going through the entire architecture. So there's a lot of advantages to using cloud events. And furthermore, what we've added here in this feature is a way to inspect the cloud event coming in to the sidecar and look at certain fields and make decisions on where that message should go into your app based on that. And so anyone that is familiar with some of the older, I won't say older, but the enterprise integration patterns, this site, like there's a link from this docs page over to that page. This sounds a lot like a content-based router and older terminology, which is exactly correct, right? So what's the scenario here? Well, the picture they've drawn is some sort of inventory system where a message comes in and there's two different backends, or the message for widgets is handled totally differently than the one for gadgets, right? So that's kind of a common use case if you've got these disparate systems in the background that you need to kind of handle the traffic or play traffic cop with. So this will allow you to do that. Furthermore, there's another enterprise integration pattern that is very similar to this called message filtering. And I will actually show kind of how these two things are really kind of one and the same, the way we've done it. But I will get to that kind of in the demo I'm going to show. But I don't know about you guys, but when I'm not working on Dapr, I love to sell widgets and gadgets. So I want to implement this in my application. So let's go ahead and jump in and see first what Dapr does for you today. So I'm going to start with a simple node application, and it's got this callback called Dapr subscribe, right? And this is called our programmatic subscriptions. Everything I'm about to show you is in that docs page, but this is kind of a live example of it. And so this is kind of what we supported prior to 1.4. Is a very simple, you specify the pub sub component, the topic, and which route in your application should receive that message. So what does that look like right now? Actually, before I get into that, I've got different messages here. So I want to be able to publish information on widgets, gadgets, and I'm also going to have a third thing called a thingamajig. I don't know what a thingamajig is, but I had to have a third thing. So thingamajig is what I picked. So as you can see, there's a description, a price, and kind of a widget specific field and a gadget specific field. And a thingamajig is just kind of a thingamajig. There's nothing special about it. But these are the three types of messages I'm going to publish into my Dapr application. So today, the application is running right now on the top. And so if I publish a widget, it doesn't really know anything special about it. It's all going to get treated as a generic product, right? So I'll show you the code for that real quick. So this is the product handler, right? And what I'd really love to have happen is widgets go to this specific route where you can just pretend that there's some business logic in here that does widget stuff. And I want gadgets to go to a different route that does gadget stuff, right? Completely different flows, but I want that to be kind of handled outside of my application. So, and just to show you, like, I can kind of send gadgets, it's the same effect, right? And then I have to move the zoom controls because I actually can't see what I'm doing. Open them up top. And where's the thingamajig? So thingamajigs, right? So all three different types of messages do the exact same thing. So now what I'm going to do is introduce the new structure for this callback to make it so that the routing is enabled. And so I'm going to comment out the previous structure and put in this new structure. And the way this works is, first, what it will do is if there's this new routes plural section here, right? And what it'll do is if you've specified rules, it will go to them in priority order from the first to the last and look for any of these matches to evaluate to true, right? And underneath the hood, there's a standard evaluation language here that's being used called cell. So, you know, we're using a fairly robust and commonly used evaluation engine for this particular feature. And so as soon as it finds a rule that evaluates to true, it'll pick the path in your application that's corresponding to that match. And if it doesn't find anything, it'll pick the default if there's one specified, right? So that's the basic structure. It's pretty simple. And so if I restart the application with this, I'm just going to clear this because it's all the Dapr startup stuff. And I'm going to post a widget, actually. Oh, interesting. Did I not? I have to save. You have to save for your code to work. Go figure. So there you go. Now I finally have the widget callback being invoked. And so you got the little screwdriver there. That's the best emoji I could find for a widget. And let's do the gadget. The gadget looks like a cell phone, and you can see that there's, you know, gadget fields in there. And just to kind of call back to what's happening is it's actually looking at this type field in the message, which is, again, a standard field inside the Cloud Events payload. So we're routing based on type. And then I don't have a route for thingamajig. So what that should do is route back again to the default product handler, which is just the generic way of handling other products other than routes and, other than gadgets and widgets. So that's basically kind of the behavior you get. I want to show you one more thing, though. I'm going to comment this out again. The way I would personally, this is just my preference, recommend you use this is the idea, the advantage of doing this is just moving this if then else logic completely outside your application because it's more infrastructure-y than it is business logic, right? So what I'm gonna do is I'm gonna comment out this route, and I'm gonna go to a subscription CRD, which we have a new version of it in this version that Hal alluded to. And I'm gonna take this disabled off of it so that the runtime actually picks it up. And if you look in here, it's basically the same structure, but in YAML form. So I no longer have to have this callback in my code that has all that JSON stuff in it. I can just put it into the configuration there. And I will go through, I'm not gonna do all three things again, but I'll just show you the, I've done something. Oh, I did not update this. So actually I have to do this in real time here. So all right, I actually have to inventory. So for whatever reason, I did not update this part of the demo, but no worries. And just so you know, like I'm actually making this application a quick start. So I'd like to go ahead and submit this to the quick start so everyone has access to it. So there we go, we fixed it. The gadgets are coming through and that's basically it. So one thing I will say to get filtering is all you really have to do to get filtering is just comment out your default route. So in other words, it's going to filter out any uninteresting messages to the application. And there you go. You've got content-based routing and message filtering all in the same feature. And with that, I will stop sharing.
Great, thank you, Phil. And indeed, I think this is another feature in version 1.4, like you said, that aim to give more flexibility and make your life a little easier. First was what your own said with service location, now with PubSub. Yeah, so let's go on to the next topic, which is Dapr Logging. And we got Sandra and Edwin here. They're going to talk about that. So take it away.
Yeah, thanks, Ori. So yeah, let me start sharing my screen because I always forget that. Just to share. All right. So yeah, a couple of weeks ago, Edwin and I had a meeting with Mark, some of the other members of the team, and we discussed whether or not it would be useful to add an application level logging building block to Dapr. So that's a question that pops up from time to time. Dapr offers a lot of functionality around observability. So it's natural to ask if those features extend to the application logging itself as well. So in that meeting, we basically reached a conclusion that it's not really worth the effort. And Mark asked us to jump onto this community call to explain the reasoning, as well as to gather any additional feedback around this topic. So to start this off, let's quickly recap Dapr observability features. So Dapr supports distributed tracing backends by exposing a Zipkin or OpenTelemetry endpoint. Dapr supports metrics, which are supported through a Prometheus compatible endpoint. And then finally, log entries from the sidecars themselves are written to the console. And you can then, for example, use Fluentd to scrape those logs and push them into a monitoring tool, such as Elasticstack or any other monitoring tool. So the thing that's missing from this picture is, what do we do with application level logging? Now, you can probably imagine Dapr offering a separate building block for application level logging, and it would probably look a little bit like this. It adheres to the sidecar pattern we know and love. So an application could call an API on its sidecar to write an entry to the log, and then that sidecar would then either forward the log entry to a configured sync through something like logging components or write it to the console output. So question is this useful or not? Now, to get a better feel for that, let's have a look at eShop on Dapr, which is a semi-real world scenario. So eShop on Dapr is a port of eShop on containers, which in turn is an open source .NET reference application. And eShop on Dapr replaces a lot of code in eShop on containers with simple calls to Dapr sidecars. Now, if you look at logging in the original eShop on container solution, you would see a lot of logging dealing with what commands and events are communicated between the services. So for example, in this top snippet, you can see an informational log entry written just before a create order draft command is published. And then in the bottom snippet, you can see the logging that is done when that command is handled. Now in eShop on Dapr, we get this kind of logging basically for free thanks to the distributed tracing features of Dapr. So let me show you that in action by switching over to eShop on Dapr. So this is actually a new version of eShop on Dapr. This front end has been completely rewritten using Blazor. So this is now running in the browser, in the browser on Blazor WebAssembly. These changes haven't been merged in the main branch yet, but the plan is to do that before the end of the month. So let me just order some nice Dapr swag here. Let's get a cap, maybe a hoodie. So now I've got 2 items in my basket, and if I click on that, we can quickly go through the checkout process, place my order. So now I've placed that order, and I can go into Zipkin to view all the distributed traces of this little process. So you can see that I've got a checkout process here, and if I click into the details, you can see all the calls made between the services and also between the sidecars. Zipkin also has this very nice dependency graph. So if I click here, you can basically get a map of the entire solution. And I'm using Zipkin to view the traces, but you can also use the OpenTelemetry collector to push traces to all kinds of different tracing backends. So this is the distributed tracing part, but eShop on Dapr also contains more basic application level logging. So for example, in this snippet, we log on entry whenever the user's basket is updated. Now the question is, how do we want to make this type of logging accessible to the developers or the operators of the application? And personally, I would like this log entry to show up in the same place where the logs of the Dapr sidecar itself end up, because that will give me a holistic view of my entire application. Now consider this diagram of the application. So here's the eShop basket API running in a container along with its sidecar. And the Dapr sidecar logs are outputted to the console. So if we want these to show up anywhere else, we need to parse them from those container logs. And we can do that using, for instance, FluentD. And then again, FluentD can output those parse logs to a sink such as Elasticsearch. Now in the eShop application code, we use, which is .NET code, by the way, we use Serilog as the logging framework. And we've configured Serilog to also just simply write the logs to the console. So now we can do the same as with the Dapr sidecar logging and have FluentD parse the log entries and push them up to Elastic. And by the way, Serilog has support for many, many different sinks. So as an alternative, we could also configure a dedicated Elasticsearch sink with Serilog and then push the log entries directly to Elasticsearch. But in this sample, I'm going to use FluentD. Now, good news is that there's this great tutorial in the Dapr documentation, which shows you exactly how to set up FluentD, Elasticsearch, and Kibana to get your logs into the Elastic Stack. So I went through that tutorial and that made the logs available in Kibana. Now, as I said, on the application side, all I did was write the log output to the console. And I'm really focused on .NET here, but of course, writing to the console can be done on any platform. So let's have a look at the results in Kibana. So let me try to get my Zoom title bar after. Actually, let me close this one because my tab is a little bit hidden behind the Zoom bar. Okay, so I've got both my application and sidecar logs here now in the same Elasticsearch instance. And here you can see that I filtered this view on scope Dapr runtime. That means that right now I'm only seeing logs that are published by the Dapr sidecar. And there's a lot of interesting information here. You can find your application ID. Fluentd also adds a lot of details around which container it came from, which needed service, etc. And then you've got the actual log message, as well as the version, for instance, of Dapr. So I've got all my sidecar logging here. But if I now remove that filter and then maybe filter for something else, so let me type in successfully. Here I see all basket items persisted successfully messages, which is not something that the Dapr sidecar logs, but that's something that my application specifically logs. So now that I have all that information here in this central place, I can very easily monitor my logs from this single location. So this brings me back to our initial question. Does it make sense for Dapr to offer a building block specifically designed for application level logging? And we think the answer is no, for a couple of reasons. First of all, .NET, as well as almost any other platform, already has very high quality mature logging frameworks in place. So any Dapr building block would need to offer at least some feature parity with those logging frameworks. And that means that there will be quite large opportunity cost. And we actually think that there are other more complex aspects of distributed systems programming that are much more interesting for Dapr to solve than to focus on the simple logging, application logging. Whichever way you go, you should always have like a plan B for how do you get insights in what's happening if your application cannot even create log output. So if you would create a building block, that would involve a network call. It's a local network call, but still it's a call to another process, to that sidecar. And what if that fails? Then how do you get your logging? Maybe write it to the console, but then you're back at square one and you still need to have something collect that log and push it up to Elasticsearch or what have you. So all in all, it's already pretty easy to get both application and sidecar logs set up. And we don't think there's much that Dapr can additionally bring to the table as a value add here. So that is basically the 10-minute management summary of our previous meeting. We are very curious if you have any feedback or scenarios that we may have missed, or any feature or requirements that we may have missed. So I think it would be best if maybe post it to the chat. I don't know how much time we have left, Ori, but maybe we keep the discussions up to the end and post any feedback in the chat.
Yeah, I think we can do that if we have time left, and we can also, obviously, as always, continue the discussion on Discord. I think we might even have an observability channel, but I'm not sure. I need to check that.
Yeah, there is. Yeah.
Yeah. And yeah, so I don't know if anybody else has some comments. You feel free to drop them in the chat, and we can unmute you as well. But for now, maybe while people are kind of thinking about that, I'll let Xavier speak to the new JavaScript SDK. Xavier.
Yes, fantastic. Hi, everyone. Good morning, good evening, depending on where you are. So let me just quickly share my screen as well. There we go. Are you able to see that?
Yeah.
Okay, so thanks for the introduction. So yeah, we're happy to announce that the new JavaScript SDK was actually created and released to make it more easy to interact with JavaScript language on Dapr. So it was just merged, so we call it version 1.0 at the moment, because it was a complete rewrite, and we think it's at the moment stable enough to be used in projects. And it's actually created to make a more streamlined API that here you can find an example of that aligns with the TypeScript language. as well. It allows you to create more stable applications and as well seamlessly switch between HTTP or gRPC. Well, the previous one was more focused on gRPC by itself. On feature parity as well, it's now also more up to date with the latest version of Dapr, also including actors, for example. So an actor runtime is also included in it. To give maybe a quick demonstration of that. So when you open the repository, one of the folders you will see is an examples folder that was added with code examples for gRPC and HTTP. So the different communication protocols within their subfolders depending on the use case. So one of the use cases I wanted to highlight here is, for example, the pub/sub use case. So if you open that, you will see that there's just one dependency you will have to add. That's the Dapr client. That is now published on npm as well. So you can just go to the npm repository registry, download or install with npm install the Dapr client. Then you will instantly get access to that. Then you just have to create a TypeScript file where you import the Dapr server and Dapr client depending on what your application needs. So the Dapr client interacts with the sidecar, while the Dapr server actually exposes your application to the sidecar so that the sidecar can interact with your application. So for a pub/sub example, we have a publish, we have a subscribe. So for subscribing, we typically create an application that will listen on an event being published to it. So that's the server side. And then we want to publish, we go through the sidecar that then will take care of all the event handling for us. And then we actually publish it and we use the client for that. So to make this example, it's quite straightforward as well. So we create a server, we initialize that. We say, okay, we want our server to be running on a specific host. We will want it to run on a specific port. And we also want to let it know where the Dapr sidecar is being hosted at. Then for the client, we do the same, but we don't need server host and server ports. We just say, where is the sidecar sitting? Where do we need to communicate with? And then for our server, we start everything up. So we say for our server, okay, I want a subscribe endpoint available. I give it my component name that I wanted to listen on, that is registered here. So in the components folder, if you're not using Kubernetes, so if you're just using the self-hosted one, or else if you're using the Kubernetes one, the deployed one. And then you say, okay, the topic you want to subscribe to. And then all the data that will be sent to it, you can instantly process through one of the callbacks in there. Then you say, okay, the server is now ready for the subscription. So the route is created where it needs to listen on, and now start your server. This is an important step because you cannot dynamically after boot up of the application change the route. So you first need to register the route, and then you need to let Dapr know that the route is there, it is registered, and then it should pick it up. Then to send a message, we do the same, but then we just use the client instead. And we say, okay, clients, again, pub/sub. We publish, we give it a component name again, so we know which event handler to use, which topic to send to, and which data we want to send to it. And then when we run that through the Dapr sidecar mechanism, such as Dapr run, you will see that, okay, the application starts up. So we start listening on a port. We register one of our pub/sub subscriptions. We wait till Dapr picks up the server so that we know that it's there, that it's listening to requests. And then we wait for events. And then you will see instantly the pub/sub is sending an event here on the publish, and we will instantly receive that. So all of this as well is now available in the documentation as well. So you can instantly go to the documentation on the docs, the Dapr docs website, where you will see an overview of the client and some of the examples. So if you go to client, you can find per different feature sets. So for example, how to interact with secrets, how to get those secrets, how to create them, how to interact with actors. We're working on that. It's also going to be added soon. How to invoke a service, how to work with your application state. All of that is now described in the documentation as well.
Yeah, and this is really a terrific, in general, rework of the JavaScript SDK. There was like an initial version. I think, I mean, we still consider it in preview, but this is a great step forward to making it another stable SDK for people to use. I know Nick has also done a lot of work on this documentation. Nick, if you want to chime in, I think we're still looking to maybe extend some of the examples, right, in the repo?
Yeah, this is very much just an initial pass at getting most of the building block examples in, but I think Xavier and myself will work to add, we'll do work to add some other examples, runnable examples, and also how to use actors with the SDK. So that's coming soon.
Yeah, and I think we might find maybe a future community call where we can maybe do a deeper dive into this, especially after you also add some of the actor stuff. I think that would be terrific.
Yeah, indeed. So we're definitely looking forward to the community's feedback, of course, on this. So if you're working with it, if you tried it out, if you find any issues, feel free to instantly raise them. We will work and do our best to solve those as quickly as possible. And we really hope that it's a step up from the previous SDK, so it's easier to interact with everything and that it allows you to instantly get started with Dapr. And then I will now stop the sharing. Thank you very much.
Great. Thank you so much. So thanks to all the presenters for being really good on time. By the way, I really appreciate that. We talked about a lot of stuff here. So I think we have a little bit of time for some questions, or maybe kind of going back to some of the discussions we had earlier. If there's anything on the chat, I'll just go over it. But if anybody has anything they want to kind of call back to, please chime in. I think there's a question here about the logging, about structured logs. I know Sander and Edwin, if you want to speak to that.
Let me see. Yeah, most logging frameworks support structured logging, but the structure is diluted or lost when pushing logs to standard out. That is totally true, because then it's all flattened out and you lose those variables and parameters. So in that case, you would probably, if I look at the issue op solution, that would be pretty easily fixed by just having a sink with Serilog that supports structured logging. So that would be a little bit, for eShop would be a big problem because it's just configuration change. So it kind of depends on the platform how big a change it's going to be. But even then, I think most platforms have some pretty mature structured logging frameworks.
Yeah, and to add to that, if you look at the Dapr logging, you can use JSON logging. So the actual log entry will be a JSON piece of JSON. And what you could do, of course, in Elastic or in some in-between system that you use, you could interpret this JSON and then index the individual fields that are inside of the logging data. And then you could actually search on these fields. That's also actually how the structured logging in Serilog works. So I use Seek a lot, which is a really simple server to use for logging and for looking at logging. So kind of a monitoring backend. And then this interprets the JSON, and then you can search on the individual fields. So you have to do a little bit more work on that, but that's in the monitoring backend. But you can just log the JSON to the output just as Dapr does that if you have JSON logging enabled. I don't know if that answers the question, but that's one way of making more sense of this logging data.
Thank you. I think there was an earlier question also regarding the 1.31 upgrade and zero downtime upgrades in general. I think Federico, you mentioned you have a use case where you're actually not running on Kubernetes. I'm actually going to let you unmute if you want to speak to that a little bit more.
Right. So thank you for unmuting me. So yeah, we are planning on deploying the application to AWS, CCS, and Fargate. Unfortunately, we are not targeting to use Kubernetes, but I believe the upgrade path would still have zero downtime, if I'm not mistaken, right? Because we would be deploying each of the ECS tasks that are composed of both the application and sidecar. So that's one ECS task. So we would be deploying the new version each time. So I would leave that work either way, if I'm not mistaken.
Hey, Federico, first of all, don't apologize for not using Kubernetes. Look, there's other platforms other than Kubernetes in the world. It's fine. You know, and Dapr was really meant to run in those. So it's great to see you're using self-hosted. Let me ask you this: are you using any of the Dapr control plane components? Like, are you using Sentry for MTLS, or are you deploying the placement service, or is it just the Dapr sidecars that are injected into the ECS pods?
So at this point, there is no Sentry container that we would be deploying, as we are not enabling MTLS so far, but we are going to be using the placement service as we are leveraging the actors building block. So yeah, at this point, it's just the placement service.
Right. Okay. So the only downtime you need to take into account when you upgrade in terms of, you know, control plane sidecar communications is really the placement service. And so are you running multiple instances of it?
No, just one.
Okay, so what I will do is run 3 replicas of it, which is the same as our highly available setup for Kubernetes. And then with ECS, you will need to do a rolling update for your ECS clusters and update the placement service. And what that will do is basically allow the sidecars to reestablish connections to another active instance of the placement service. So, you know, you won't have downtime for existing actors, but if you're upgrading and new instances get added or removed from your ECS cluster, then if you're only having a single instance of the placement service, you won't be able to schedule new actors on top of those new nodes. That's why you would want to run the placement service in a highly available manner. Does that make sense?
Yep, it does. Thank you for the suggestion.
Yep, no problem. And oh, but by the way, it's a really interesting use case. So, you know, if you want to hop on this community call somewhere in the future and show everyone, you know, exactly what you're doing, I think like Dapr and ECS is an extremely interesting scenario for the entire community to see. So we would be really happy to see that.
All right, I will let you know, guys know, and maybe
Yeah,
we can
absolutely.
set something up.
And also, I want to kind of also mention that we have the Dapr blog, and we're always interested in seeing community guest authors publishing on the Dapr blog. And maybe you've seen recently, we did kind of like a case study for Dapr on Autonavi, which is a Chinese navigation application. Very interesting how they're using Dapr. So anybody here who has a real world use of Dapr that might be like, just like you, Federico, doing something that's a little different, or I think kind of like what you're saying, very beneficial for the community to learn more about that. So I'm happy to work with anybody who has any suggestions. Please feel free to reach out to me, either on Discord or on Twitter. So I don't know, do we have any more questions? I'm trying to scan through this. I think most of the stuff has been answered on the chat, but please, if there are additional things you want to discuss, feel free to move to Discord. And also, you know, the next community call, as always, we try to have open discussions. We're still doing these community calls at every 2 weeks, and we're trying to alternate between this time right now, which is morning in the West US time zone, and probably more convenient to US and Europe time zones. But we also are doing another one, which is more suitable for the Asian time zone. We made that switch relatively recently, and if you're watching this as a recording and find the other time more convenient, please feel free to join on those times as well. We love to have these conversations like this and questions live in the community calls. So with that, I think we'll close this one. Thank you again, and hopefully see you next time.